Welcome to the IMETC 2000. My name is Cha Chu Ping. I'm the presenter for my group and I would like to present my paper entitled SN2 Kit in Learning Bimolecular Nucleophilic Substitution Mechanism. This is my team members. For SN2 reaction mechanism, based on years of teaching experience, we have identified a few common mistakes usually made by students when writing the mechanism. They include unable to draw 3D structure of haloalkane and identify the alpha carbon in the haloalkane. 2. Unable to draw the transition state. 3. Unable to draw the inversion configuration of the product form. Hence, the objective of our study is mainly to improve student performance in writing SN2 mechanism. This includes to increase the ability to draw the 3D structure of haloalkane, transition state, and inversion of configuration of product. 2. To use the arrow to draw the bond breaking and bond forming. 3. To determine the rate determining step. To achieve our objective, SN2 kit was constructed. SN2 kit is a kit used to help students to master the SN2 reaction mechanism. It consists of 7 bonds in 1,2, which represent all the bonding involved in the mechanism. To use the kit, students need to decide which bond involved in each step of the mechanism. This encourages students to reflect on what they have learned before to allow them to make a correct decision on which bond involved in each step of the mechanism. Furthermore, by using the kit, students' ability to visualize the 3D structure of reactant, transition state, and product of each step of mechanism. This is a video show how to use the SN2 kit. First is a backside attack by nucleophile on the alpha carbon of the haloalkane. Second is the formation of the transition state. Third is the formation of the inversion configuration of product, where the nucleophile substitute the halogen group. The target group in our study was 17 2-year matriculation science program students. Our study was conducted in 3 stages. Stage 1 was conducting the pre-test. Stage 2 is inquiry-based teaching approach with the SN2 kit and the worksheet. Stage 3 is a post-test where we will evaluate the effectiveness of SN2 kit in the teaching of mechanism. Inquiry-based teaching focuses on 5E learning cycle. This approach helps students to refine, recognize, elaborate, and recheck their misconceptions after interaction and discussion the group activity through self-reflection. Inquiry method is an approach learning that emphasizes students' role in the learning process, rather than teacher telling students that what they know. Students are encouraged to explore the material, ask questions, share ideas. This method allows students to engage in the activity and thinking actively to develop their new knowledge. Besides that, it provides opportunity for students to use their knowledge in problem solving. In engaged state, lecturers use an inverted umbrella to create the interest and stimulate the curiosity of students about what is the meaning of an inversion configuration of product during the nucleophilic substitution. Students were excited with the umbrella and could possibly imagine what does it mean by the inversion of configuration. In the explore step, first, lecturer briefed students about the task, then students discuss in the group and solve the problem in worksheet using the SN2 kit. During the process, lecturer acts as a facilitator to guide students in the learning mechanism. After completing the task, we move on to the explain step to discuss the answer in the worksheet. For this, lecturer randomly picks students to present the answer on the whiteboard using the SN2 kit. Other students were also being given the opportunity to question during the presentation. This allowed two-way interaction between students, and students will actively participate in the learning process. In the elaborate stage, students solve the question about steric hindrance effect using the SN2 kit and their knowledge regarding on the characteristic of SN2 reaction mechanism. particularly on the idea of the backside attack of a nucleophile on the alpha carbon of halocane during the reaction. In the evaluate stage, a pause test was conducted to assess students' understanding on the SN2 reaction mechanism. Mean score of a pre-test and post-test indicate an overall positive improvement of student performance in writing SN2 reaction mechanism by 36.13%. There were positive improvements in each of the items evaluated based on the objective of the study. First, the ability to draw 3D structure increased by 33.34. Ability of students to use arrow to draw the simultaneous bond breaking and bond forming had increased to 41.18%. Student ability to illustrate the backside attack by nucleophile on alpha carbon of halocane also showed the increment in performance by 35.29%. It also pinpointed an increasing by 41.81% for the ability of students to label the red deterministic correctly. After the study, we found that students able to draw 3D structure and students very participate in the process of learning and active. They give a positive feedback. So, inquiry-based learning method 5E learning process should be used with the SN2 kit to enhance effectiveness. As a conclusion, first, SN2 kit and the inquiry-based teaching approach were effective. 2. Students could visualize the 3D structure. 3. Students can use the arrow to draw the bond forming and bond breaking. 3. Students can use the arrow to draw the simultaneous bond breaking and bond forming. 4. SN2 kit can also be modified and used as a teaching kit. As I bring my presentation to a close, I once again thank you for allowing me to share about the study and hope that my sharing has given you much clear understanding of inquiry-based teaching and how our SN2 kit innovation could help students learn better in SN2 reaction mechanism. Thank you.